Okay, fine. In today's session, we will see about a linked list. It is one of the types of an linear data structures. Already we have discussed about an arrays. So in the linked list, generally in the linked list, what do you do? For example, in an array, we will give an int a of 7. That means that it will allocate a memory space of for 7 memory locations. Okay, 7 memory locations will be allocated. For example, so here, so 7 memory location has been allocated. So each location will occupies 4 bytes. Each location occupies 4 bytes. So this location 4 bytes. So each location occupies 4 bytes. So for example, in the 7 memory locations, if I am going to use only F4 elements, okay, I'm going to store only in 4 data over here. So here I have stored a data called 6753. That's a 4 datas. And then remaining 4 memory locations is always waste. Okay, the 12 bytes memory has been always wasted. Okay, so now this is the drawback which we have in an arrays. So now to overcome this drawback, we have gone for a linked list. We have gone for a linked list. So now a linked list is nothing but a collection of more data items. Collection of more data items. And then here the only peculiar thing is it will not store the data in continuous format. Where in arrays always it stores in continuous format. After memory called 1000, it will store in the 1001 or 1002, next 1003, 4, 5, 6, 7. Always to store the data in consecutive memory locations. Where in the linked list, it will not store in the consecutive memory location. That's a first difference between an array and linked list. Okay. So now in linked list, always we will use to store a data in in called node. Node. In node, it have two fields are there. One is the first field is called data field, where we will store the data, and then the another field, the next field is called an pointer field. Pointer field. One is called a data field and another is called a pointer field. So this is called a node. So now if you want to store a single data, then we will store the data in that data field. Data field. And then in pointer, what do we do? We will see. So now here, now we will construct a linked list. In a linked list, I have an so now here we can observe a first node and then second node. There are two nodes are there. So now this node might store in the memory location called an and 1000. Okay, a memory location called an 1000. The first node memory location is something called 1000. The second node might be in some different memory location. It doesn't need to be consecutive. It might be in different memory location. It might be 1012. 1012. But usually in arrays, what happens over here after 1000, 1001, 1001, 1002, 1003 like that in consecutive memory location. Where in the linked list is always different memory locations we can use it. And then here we have a data field. So I have stored 4 as a data. And then this pointer will store the address of the next node. This pointer will store the address of the next node. So pointer, what is the pointer? The pointer will always store the address of another data or another value. Okay, so now, so next node address is 1012. So here I will store the address of next node 1012, and then, so since it's pointing to the 1012, we have an arrow mark, it's pointing to the next node called 1012. In the 1012, we'll store a data called something called an 6, and then this is the last node in the linked list. This is the last node in the linked list. So here I'll give a null pointer. Here I will give a null pointer. So this is how we can create a linked list. So it doesn't need to be 50 data elements or 100 data elements. It can be infinite. You can store maximum amount of data in whichever way you want. But whereas in arrays, always we have constraint that we can store maximum of 7 or maximum of 100 or maximum of 200. So always we have constraint of maximum limit will be there. Where in the linked list, there is no limit. We can store a data at, at whichever rate we want. But here the other drawback is in arrays, wherever you want to search a data, okay, you can go and search in between. You can go and do the data search in between. But whereas a linked list, it will always go by one. Okay, at first it will go to the first node, and then through this node it goes second node, and then it will search for the data. To search for the data. But whereas in the arrays it is not the case. That's another corresponding major difference between the arrays and linked list. So now we will see that how can we create a node in a programming way. So in the node means what? We have two fields are there. The one field is for data and another field is for pointer. Where pointer is what? Pointer means what? It will store the address of an next node or another data. So now here, if you observe over here, this node have two fields where the two fields are completely different. One is an, for example, data will be always integer. So it will be an integer. It will be an integer, and another data field is the another field is called pointer. So now whenever we use corresponding different data types, okay, then we will use it by means of structure. We will define our own data type. We will define the own data type. So to define the own data type, what do? We will use it by means of structure. Okay. So now here we are going to create a structure for the node. Structure for the node. So here struct is the keyword. Struct is the keyword and node is the corresponding our structure name. Structure name. So here we have an two fields are there. One is a data field. Another one is pointer field. But here this pointer field stores the address of the another node. Stores the address of another node. Where the another node is a type of a structure. The another node is a type of a structure. Okay, the 1012. The 1012 points to the another node, where the another node is nothing but it have one data type and then one pointer. So where another node is also a type of a data structure, the struct. Okay, so now here, how do you declare the pointer over here? A struct node asterisk p. So now what is the difference over here? The corresponding the another node. So the another node is a type of an structure. The another node name is called node, and then it defines a pointer p. The p will store the address of another node. This is a structure. Okay, where structure is nothing but it stores it will we can declare the different data types under single type called a structure. So this is how we can create a node in a linked list. So now here, whenever we use a node, then we will use a keyword called struct node, struct node, struct node, struct node like that. Okay. So now here, uh, for example, if you're going to create a linked list, let me copy this. Always there will be something called an head pointer. Always there will be something called an head pointer. So this is a head pointer, where head pointer will always stores the first node address. The first node address. The first node address might be 1000. The first node address might be 1000. So here this node address is 1000, and this node address is 1012. So now what happens over here? The corresponding So in the head node, we have stored something called value called 1000, where head is the pointer. The pointer holds an address of a first node. So it holds a first node address called 1000. So it's pointing towards a first node. And then in the first node, we can find two fields over there. One is called data field, and another is called a pointer field, where pointer stores an address of a next structure node. So 1012. So 1012 is an address of a next structure node. So this is how we can define the node in the linked list. So now from now onwards we will see types of linked list, and followed by we will try to implement an every linked list. Okay.